Hi folks, I'm Mr. V. Today is Illustrative Mathematics, Chapter 5, Solid Geometry. We're slicing solids. And by the end of the day, you should be able to say, I can identify three-dimensional shapes that generate a set of cross-sections, and I can visualize and draw multiple cross-sections of a three-dimensional visual dimensional figure. And to start off with, we sliced this in as many ways as you could to get different slices. And then we did the cube, and we did that. So let me show you some of the results that we got. First, I asked my wife, I said, can you slice a circular cake to get 7 equal pieces? And she said, sure you can. And she did it this way. She sliced it. Oops, let me do this with yellow so that you can see it better. She did it this way, around here. And when you slice it in a round, you're going to get a circular cross-sectional area. And although that works, it doesn't give me the equal icing. So actually, she starts it from the middle and cuts it into 7 equal slices so that everybody gets the same amount of icing. Another possible way of cutting this would be to cut it if I were to take a section from here, say, and go straight down with my knife. This is the part that you would see. The part you would not see, I'll do in dashed. And this becomes a rectangle. And these are the most common cross-sections that students can find easily. There are other cross-sections, though. What if instead I were to do a start here, and work my way around, and go around to the back side, and then come back up? What kind of shape is that? You should get an oval if you do that. And I should do this in a darker color so that you can see it, an oval. What if I started at the top, somewhere in the middle of the top, and went down partially on the bottom? So let me see if I can erase this and try that. If I started, say, right here, let's do this in yellow, and I were to come down somewhere like this, and you can see that this is going to be some kind of a shape that's got a curve in it somehow. And I don't know if it's parabolic. It might be parabolic. It might be catatonic. I don't think so, but I think it's parabolic. I'm not sure. When we talk about cones and conic sections, if you cut a cone, it's going to be a parabola. This is going to be some kind of a curve. And if I went from the top to the bottom, that would be my last one that I think I could do. So if I could start up in the yellow, start up here, and I'm going to end down here somewhere. And if I were to slice this, it's going to go around this side. I'll do the dashed lines where you can't see it, and then do it solid. And so it's going to be some kind of a curvy shape, maybe a little bit longer on the one end, and then come down and a little bit like that, something like that. The cube is a little bit more challenging and a little bit more interesting, actually, in some ways. And these are different shapes that I could get. The most common one that people can come up with would be this square. If I were to slice it like this horizontally, I'm going to get a square. Or maybe we slice it, let's see here, just erase this. Erase. If I were to slice it on a corner, maybe like this, going down, I could get a rectangle, which would be this one. I could also slice off a corner and get a triangle. And it doesn't have to be isosceles, and it doesn't have to be it doesn't have to be, it could be like this going down. So it could be like that. So I could get a triangle when you slice this. The more interesting one is, what's a trapezoid? What do you mean a trapezoid? Or a hexagon or a pentagon. So what? You can get that off of a square. So if I were to slice it here and say down here at the bottom, and I were to connect these pieces where they go, you see this is going to be an isosceles. It's going to be a trapezoid. It might be isosceles. It might not be isosceles. I don't know if you can get this figure, which would be a trapezium. I think that these sides are going to be parallel, and I'm pretty sure they are. I'm not sure. So they might not be. Anyway, there's these different shapes that you can get. In our Desmos activity, we actually are going to experiment with GeoGebra, and you get to try to do this on your own. And you can call this up. Sometimes it takes a little longer to call up. I will call it up, and I'll show you some of the explorations that we do. Here we have a cube. and I can move this view so you can see the cube. And I have a plane. The plane is defined by 3 points, the red points. And I can move these red points around. So if I wanted to move this, I can move it up or down. I can move it to the side. If I move it to the sideways, you can see the cross section that is formed by this plane, these 3 points. If I move this all the way out, you can see it's not even there, but it starts being a triangle. It grows. Then it's a trapezoid, an isosceles trapezoid. And then it goes on to be a pentagon. And I end up with a rectangular parallelogram over here. Can I make this into a something else? Maybe I can make it into a hexagon. So if I raise this up and I go way up, no, that isn't going to work. Maybe if I raise this other side up, and you can see now I've got this figure. I'll lower this one. There, now it's a hexagon. Can you make it a regular hexagon by moving it around? If you click on the red dot, it'll change direction, whether it's going to go up and down or sideways. Okay, so you get to play around with that. Then we come to page 5. Here we have cross-sectional parallel slabs of the same three-dimensional solid. Same with these circles, and same with this. What solid are we talking about here? And on page 13 is the answer. This is a triangular pyramid. Notice if I take off the top part, it's still a larger triangle and then an even larger triangle. The second one here is a cube. And it's like our cube. We have one face, two face, three face, and the other three faces on the back side. And if you chop off the corner, you get a triangle. If you chop it off a little bit further, you get a hexagon. When you take all these circles and you stack them, you get a sphere. In this exercise, which is the more exercise, I encourage you to try it. Try to draw the three-sectional cross-sectional areas, and I give you the possible solutions here. I also give you some answers. So try answering it first yourself. What happens when you increase the thickness of the size? What does it look like? What if it's a rectangular prism? How does it affect the size on a 3D printer? And then we have this piece, which is about tomography. And maybe you've seen a CAT scan or a CT scan, is what it's sometimes called. Conventional x-rays are this way. A CAT scan gets to show you all of the insides. This is a practical, real-world application of the cross-sections of a human. And they put it through this machine, and then they take a snapshot all the way down. And they use this to diagnose different problems and to come up with a prognosis. So in earlier grades, you looked at spheres and prisms and faces and pyramids and cones and different things. And today we're talking about slicing these. You can slice a sphere, and if you slice it at an angle, it's going to be a ellipse, and then here you would have part of an ellipse. So it's not really a parabola, it's going to be part of an ellipse. If it's a cone, it would be a parabola. Here we have the final thing, and this is a test question, and this is something that you want to make sure that you are able to answer when we get to this on a test. Here I have this. So if you were to slice this pyramid, and it might be a pyramid or a cone or something else that you're going to be slicing on the test, but if I were to slice this horizontally, what would it result in? So I'll slice it here, here. On the back side, it's going to go over there, over there. And what would this figure be? It would be either a rectangle, or if it's a square pyramid, it'd be a square. What if instead I sliced it from the top going down? And I could slice it at an angle, or I could slice it straight down like this. And I'm going to go across and then up. And this would be a triangle. This area here would end up being a triangle if it goes from the vertex. Finally, if I were to slice it at an angle, so I'm going to take this, I'm going to slice it right here. I'll go across parallel to this other side, and I'll go up at the other side. What kind of shape is this? And you should find that it's an isosceles trapezoid. So that's what you should end up with. And I wish you every success, good luck and success. That's all I've got for today. Thanks.